Hello my dear PU2 champions, how are you all doing? Good? Yes. So welcome back to our channel Deeksha Karnataka. Why I'm here today? I'm here in the second session for maths, which is the chapter Inverse Trigonometric Functions of your Brahmastra 2.0. Okay, so as we discussed in our previous live, inverse trigonometric function does sometimes feel tricky, even though it's very easy, but the questions framing are sometimes trickier and we end up making mistakes. So for all of that confusions, I'm here to take them out one by one. So we'll discuss questions, we'll discuss everything, we'll show you everything. Just tell me, how are you feeling about the Brahmastra series? Is it helping you? Do you want us to add something in that? And if you are here for the first time, if you have not subscribed the channel yet, do subscribe Deeksha Karnataka, because we are bringing everything that you need to get the top score, the top 95% score in your PCM for PCMB for your boards, right? So do let us know, how do you feel about the sessions? Give me a thumbs up if you like the video, and let's start the session right away. So first thing first, in the Brahmastra 2.0, the chapter is inverse trigonometric function, and we have here the latest weightage from the blueprint. Okay, so we have three categories of questions coming from this particular chapter, which makes total of 3 questions and total marks of 6. 1 question from the single 1 marker, 1 question from the short answer 2 marker, other question 1 marker from short answer 3 marker. Total 3 questions, 1, 2, 3 is the total marks, and it becomes 6 in total. That's your weightage. Now what I have brought for all of you in this session is very simple. What are they expecting? We're gonna solve just that. Okay, so I brought 8 MCQs. Okay, then I brought next is 4 2-marker questions and 5 3-marker question. Okay, and apart from that, I'm gonna do the revision for all of you. Revision, yes, I'll do the revision part as well, and then I'll give you some homework. I have I'm a little bit disappointed. I'm still to receive the answers for the homework question of relation and function. Do give me the answers of that, and I'm here to give you 3 more questions for homework of the inverse trigonometric function. Okay, and last I'll tell you the most important topics from where the questions can be expected directly even this year in the examination. Okay, and do trust me, in all the process that I'm giving you, all the stats that I'm giving you are very important. All the questions that I'm giving you are extremely important questions, means these are the must solve questions. If you skip this, you lose marks. These are the must solve questions in your chapter in the examination of PU2. If you will skip this, you lose marks, because these questions are taken from, these problems right here are taken from your model question paper, from NCERT and from your PYQs. Okay, so becomes very important to understand and solve it. First thing first, so we know that if we talk about the concept part, the revision of inverse trigonometric function, what all is there, sir? Starting my favorite, graphical part. The graph of the top 3 functions are very important: sine inverse, cos inverse, tan inverse. Others are not that important for our board's point of view, but yes, the first 3 are very important. Next comes your domain and range. Yes, and afterwards, after that domain and range part will be your properties based questions. So we'll see all of that. Properties, when I say negative angle and all of that I'll teach you with the help of questions only. But right now we'll discuss graph and the domain and range. Now graph. So we know that there's a name to this. What is the name of the chapter? The name is ITF. If I break it down, we get 2 parts to it, which is inverse is the first part and trigonometric function is the second part. Trigonometric functions have been learnt or not? Yes, we have, sir. Where have we learnt it? We have learnt in PU1. Yes, some of it we have learnt as entities in grade 10 also, but majorly we have learnt the trigonometric functions and equations in our PU1. All of you agree? Okay. Inverse, so that we have learnt in PU2 only, inverse of a function. So we're gonna apply them together in this particular chapter. Okay, so we have trigonometric functions, for example sine, cos, tan, and so on. Inverse, we'll try to find their inverse. What is inverse? Inverse of function is basically the mirror image. If you draw the graph of the function, the mirror image of the function about y equal to x line. So if you take this as the mirror, this line as the mirror, whatever is the graph, it will become mirror image of the original function. This much is okay. Difficulty in understanding, we have a different approach also. The domain of the function and the range of the function will interchange. So domain becomes range and range becomes domain. Let me write it like this. So if I write a function, let's say f of x, okay, from a to b, let me say it is 1 to 1 on 2 only. So a is the A is the domain and B is the range. Usually when they write the function, it is what? A is domain and B is codomain. I'm saying that assume it is an onto function. So it's going to be A range, A domain, B range. Okay. So A, B. If I'm writing B inverse, no, the answer will become B2A. Can you see over here carefully? B comes here, means B becomes the domain of the inverse function, whereas the A becomes the range of the inverse function. So this is what you define inverse with what? With what? With your algebraic way, graphical way. This is the understanding. Mirror image about the y equal to x line. Clear? 2 points are clear, no? Next is what? When can we say the given function is inverse, sir? Is all the function inverse? Sir, do we really need to know this question? You might ask me, sir, do we really need to know this question? Yes. If you don't ask yourself this question, when can we say the given function is inverse? When can we call a given function, function invertible? Sounds familiar, right? This statement, invertible, sounds familiar. Yes, because you've learned in PU2 first chapter. So yes, when can we call a given function invertible? Is it relevant? Yes, it is. Because let me define invertible for you. Invertible function are those functions which is bijective in nature. When fx is bijective in nature, then it becomes invertible. Any function which is bijective in nature becomes invertible. Okay, sir, you said it, I accept it. Meaning of bijective, sir, can you recall once? Yes, I will. Bijective functions are what? A function which is 1, 1, and onto. Both. Means it should have unique mapping and also it should have basically range and codomain equal. Okay, sir. Agreed. This much is okay, sir. You said invertible we need. What is invertible? Means bijective. Bijective is 1, 1 on 2. That much is okay. Sir, how is this related to the inverse trigonometric function? I'll go to this. Forget about inverse right now. We know that will change. Once we find the original function, we know how to make inverse of it. We can take the domain and range different. We'll make the inverse operation, or we'll take the image across the y equal to x curve, graphical approach. We know how to do it, okay? That much we know how to do it. But what about trigonometric function? How does it converse into, how does this will be following this condition of invertible? Let's try and understand this. Y equal to sin x. Y equal to sin x, first graph, my favorite, the easiest, okay? Let's draw the graph. Sir, this is wrong. Is it wrong really? All of you, tell me, do you remember the graph of y equal to sin x? Yes, you do. Even though it's a recorded session, I do watch your comments. I might be late, so leave your comments in the live comments when it is streamed, or you can leave in the comment section also. I will be watching your comments and replying it to it, okay? There only I'll reply that time itself. So let me know whether it is a sine function or not. What is the answer? Yes, it is the sine function. Okay, now what happens with the sine function? Check, sir. Is it invertible, sir? Do a horizontal line test. Check. 1, 2, 3, 4, 5, 6 points. What happens to one function? It should have only one intersection. Only one intersection should be there. But I have how many intersection? So many. Then what we actually do is we do something called as truncate the domain. Something called as truncate the domain. Can we truncate anyway? No. Truncate the domain keeping the range same. Keeping range same or constant. So without changing the range of the given function, which function? Sin x. What is the range here? Sir, -1 to 1. What's the domain here? Sir, all real. So we're gonna make a restriction on the domain without changing the range. So we'll look for that part of the function, and when I show you, you'll understand this very clearly. Okay, so basically I'm gonna break it down over here. Check. If I break like this, and this is my major graph, only this much. Check, what is the domain? Domain is, sir, -π/2, sir, to π/2. Domain is -π/2 to π/2. What about range? Sir, -1 to 1. This value right here is -1, sir, and this value right here is, sir, 1. Is the range changed? No. Did we get the truncation? Yes. Is it 1, 1? Yes. Because if you check the yellow line, it has only one intersection, sir. It has only one intersection, sir. So we can say the given function y equal to sin x is now 1, 1. On 2 because range and domain are equal. So basically my range and domain are equal. Range is not changed. So what I have got? I have got the given function y equal to sin x, where from the domain minus pi by 2 to pi by 2. This is the truncated domain keeping the same range as minus 1 to 1. Now it is invertible, and I'm going to apply the invertible condition only to this marked part. And when you do that, you end up with this. When you apply that, you end up with this. This is the marked part. You check here. This is the marked part. Excuse me. This right here is the marked part. This right here is the marked part. And you take the image of this about which line? About this line. I'll show you. About this line. What line is this, sir? Y equal to x line. This will come. This here. This curve will become like this. It will become like this. Okay, something like this will become. Okay, I want to erase this because it's too confusing, but you're getting my point, right? You're getting my point at least. Yes, sir, getting it. So you check here carefully. This part here is taking mirror image and it's coming like this. And same goes to this part also. It comes like this downwards. It will be moving towards me. So same part is here moving towards me. So this is your graph of sine inverse of x with the changes. What is this? Y equal to sine inverse of x. Domain, sir. Domain is going to be what? Of course, minus 1 to 1. And what is the range, sir? Range will become what? Range will become minus pi by 2 to pi by 2. Right? In this case, what was the domain, sir? Domain was, sir, minus pi by 2 to pi by 2. Sir, it was all real. No, it was not all real. We made the intersection. We made the restriction on the domain. So this is the new domain now, and the range is what? Range is minus 1 to 1. Now check, they are reversed. Excuse me, they are reversed. Okay, they are reversed. All right. This is your understanding how to obtain the graph of inverse trigonometric function. Okay, same you go for cos inverse also. This is the cos graph. No, it is not, sir. Is it really not the cos graph? Check here. This is a cos graph. Y equal to cos x. Domain, what is domain here? All real, sir. Sorry, not all real. You have to make the change, right? We are truncating it, no? So 0 to pi, sir. What is the range? Range will be same. Minus 1 to 1. What did I say? Truncate. Apply the restriction on the basis of range keeping as it is. And over here you check. This mirror image, if you take about this line, no? This is the line over here. Check. This is y equal to x line. This part here will go like this, no? Something like this, right? This part here will go something like this. Yeah? Correct, no? This will be, it's not very smooth, but you're getting my point, no? This part here is like this. Okay? And this part will become this one. This part will be taken over here. This small part will be over here. So that is my mirror image about y equal to x line. So I hope this is clear. I'll erase this part. Okay. Once you do that, you'll get this curve, and your domain is what in this case? Domain is going to be minus 1 to 1. And what is your range? Range will be what, dear? It will be 0 to pi. Of course, you should know that for any inverse trigonometric function, output, the outcome, the result out of the given function will always be an angle. Will always be an angle. Okay, this is clear, right? Cos inverse of x, this is y equal to cos inverse of x. This is y equal to cos x. Okay, clear? Simple things, okay, not difficult, very, very simple things. All right, next, the most important one as well, and we're going to discuss only till this part, tan inverse, because that's what is relevant for our syllabus. That is going to be good enough. Okay, what is this curve? Y equal to tan x. This curve is y equal to tan x. Domain is what in this case? Domain is, please check here, minus 1 to 1, right? Domain is going to be all infinity. Sorry. Domain is a tan x, no? My bad, guys. Domain is here minus, excuse me, some mistake is there in this. Yes, the mistake is this is the mistake. Good that I saw it. The values are mistake actually, sir. This is a mistake. Okay, this is not required. This is wrong. Let me strike it out for you and I'll write the correct ones. Okay. This over here is minus pi by 2. This here is pi by 2. Okay. And this is going to be what? Till infinity. So plus infinity. And this here is minus infinity. Okay. So this, the number which is written now, it was wrong actually. I made the change. No problem. So now what we have? What is the domain? Here you check. Minus pi by 2 to pi by 2. Open. Because if you check at pi by 2, it will become infinity. Plus infinity. Over here it is negative infinity. So we can't keep it open. We can't keep it closed actually. What is the range? Range is all real, na? From minus to plus infinity. From minus to plus infinity. What about in the case of tan inverse? Check here. So this is going to what? The domain becomes what? All real, because this is going to be negative infinity. This is going to be plus infinity. It is moving on till plus infinity. Right? X is all real. What about range? The range becomes minus pi by 2 to pi by 2 open. Clear? Both are clear. Now there comes your table. Table of all. First we already discussed, for cot inverse we have domain all real and range is 0 to pi. For cosec inverse we have more than 1 or less than minus 1. And this is again minus pi by 2 to pi by 2. The except for 0, because sine 0 is 0. So reciprocal will be undefined. Sine 0 is 0, sir. So reciprocal cannot be defined. That's why it is like that. Okay. Here again we have for second inverse less than minus 1 or more than minus 1, and for range what we have 0 to pi except for pi by 2, because cos pi by 2 is 0, so it becomes basically what? Sec will be undefined. So this is your table for domain and range. Now I have to start solving your questions. Clear na? Now sir, properties you forget. I do not forget the property. I can write it over here if you want me to. So sine inverse, I'll write it with the help of questions, but it's okay, I'm gonna write it over here also. This is minus sine inverse of x. Okay, we have tan inverse, also same property, minus tan inverse of x. For cos inverse is different, pi minus cos inverse of x. Okay, and for tan, so sine is there, no? Cosec will follow the same as sine inverse. Cosec will follow the same as sine inverse, and cot will also follow the same. The cot will go with this actually, because cot has excuse me, yeah. So cot, no, here I'm not able to get the marker. Okay, where is it? It's here, no? Where is it? 1 second, sir. Yeah, it's here. Just a second, sorry. So cot will follow this rule, no? Cot will follow this one, and even the sec inverse will follow this one only. These two will follow the cos inverse because they have both cos in it. That's why we're gonna go with this one. Clear? So the negative will become as negative only for cos inverse, means we can take the minus sign out for these two. Okay, odd functions. Okay, sine, cosec and tan inverse is odd function, others we can't say. All right, sir. So this is clear. This is clear. Now we'll move on to, we have one more property, sorry. This is very, very important. Sine inverse of x plus cos inverse of x is going to be what? Always pi by 2. Always pi by 2. Same goes in the case of tan and cot also. Tan and cot also. Same thing. Same goes over here. But again, you have all the properties and formulas listed in your NCERT summary. Do go ahead and check it out. Okay, but I'm going to give you a formula sheet very soon. If you want me to, I'll give you a formula sheet very, very soon. Let's start solving the question number 1. Principal value branch of cot inverse of x. Principal value branch of cot inverse of x. Clear? Simple? Okay. Again, for this one, check the property wala question. Minus cosec inverse of root 2. So I get minus pi by 4. Option A. Third one, the value of tan inverse of this is a basically what you call expression. We are going to solve it. What's going to get? Solve it from here. Pi by 4. Here we'll get what? Pi minus cos inverse of 1 by 2. And we have over here minus sine inverse of 1 by 2, no? It'll become pi by 6, I guess. Right? Correct, no? It'll become pi by 6. Sine inverse of minus 1 by 2 will become minus sine inverse of 1 by 2. So it becomes pi by 6. Okay, sir. Pi by 4 plus pi minus this value. Pi by 3 minus pi by 6. Okay, minus 5 by 6, let's take LCM now. LCM is going to be 12 only, right? 4 3s are, so 3 pi plus 12 pi, 3 4s are, so what we have? Minus 4 pi minus 6 into 2, 2 pi. What is the difference? Check here. 15 minus 6, so 9 pi by 12, which is nothing but 3 pi by 4. Option B is correct. Option B is the right choice. If you're not getting it, do one thing, do your own calculation. Okay, if you have a doubt, ask me in the comment section. Okay, fourth one, sine of pi by 3 minus sine inverse of minus 1 by 2. We can solve it again, very simple. Check here, sine pi by 3 as it is, take formula of sine inverse into of minus value, it will become minus of minus, this will come out, so plus sine inverse of 1 by 2 is how much? Pi by 6. 30 plus 60, 30 plus 60 is 90, sine 90 is 1, so option D. This is 30, this is 60, 90, sine 90 is 1. Fifth one, question number 5, value of tan inverse of 2 cos, same approach. Okay, check here, we'll keep tan inverse as it is, 2 is there, cos is there, we have 2 sine inverse, right? So we're gonna get this as 2 as it is into pi by 6, 2 3s are, cos pi by 3 is how much? So tan inverse will be as it is first of all, cos of pi by 3, so cos 60, again 1 by 2, 2 and 2 cancel, tan inverse of 1, pi by 4, option D. Option D. Okay, 3 more MCQs to go, 3 more MCQs, let's solve them. Principal value of sine inverse of this. Okay, sine inverse of, we're going to use quadrant rule over here, 3 pi by 5. So sine inverse of sine of pi minus 2 pi by 5. Correct na? Pi minus 2 pi by 5. Check here please. This will become same as 3 pi by 5. This angle is same as 3 pi by 5. Okay. Now this angle, this is pi. This angle is in which quadrant? Second quadrant. Pi minus some angle will be in second quadrant. Second quadrant, sine is positive or negative? Sine is positive in second quadrant. So I'll get what? Sine inverse at pi will be sine only 2 pi by 5 and will be positive because of second quadrant. Quadrant rule you know, right? Okay. Apply these two. You'll have the answer as 2 pi by 5. What is the answer? 2 pi by 5. Option C is correct. Option C is correct. Clear? Okay. 7th, value of cot inverse of 1 upon root of x square minus 1. Now from here onwards you have to use some substitutions because we have cot inverse outside. To solve it I need to get what? Cot inside. Check. Take x as sec theta. So you'll have x square minus 1 as sec square theta minus 1. So you'll have this as tan square theta. How come, sir? The first identities that we have learned in grade 10. Sec square minus 1 is tan square. Apply root to this. What's the answer? Tan theta. Answer is tan theta. Okay. Because we are looking only for positive values or more than 1. Okay. Check here. Cot inverse of 1 upon tan theta will become cot inverse of 1 by tan. Cot theta. Answer is theta. X is sec theta means theta is sec inverse of x. Option C. Option C. Clear? Done? No problem. Last MCQ. Cos inverse of 4x cube minus 3x equals 3 cos inverse of x. Hold good for what? Just check here, just for contradiction. Check what you're going to put x value to solve this equation. You're going to put x as cos theta. Then no problem. Then no problem. Okay. Check here what is do we have? 3 theta. And this will lie between where to where? Of course 0 to pi. Of course 0 to pi. Correct? No? It lie from 0 to pi. Move on this side. What are you going to get? You'll get this as 0 theta pi by 3. Take cos on both sides. So cos 0 cos theta, excuse me, cos theta and cos pi by 3. Cos is a decreasing function. What will happen? Inequality will reverse. does less than equal to becomes greater than equal to. Here also same thing. Cos 0 is 1, cos theta is x, 1 by 2. Answer is 1 by 2 comma 1 both closed. Option B. Option B. 8th is option B. Please check. Clear? Clear, right? This is no problem. Moving on to your 2 marker now. First 8 questions. I hope there is no doubt. If you have, what are you gonna do? Ask in the comment section. 2 marker now. Question number 9. Write the following function in the simplest form. Simplify this. This is a substitution method. A equals to, we're gonna take what? I have tan inverse over here. I need to get tan inside. So x equals to, x equals to, right? X equals to a sine theta. So x by a equals to sine theta. So theta equals to sine inverse of x by a. Why did I find this? Because of course, so the question is given in the form of variable x, sir. We have to write the answer in terms of variable x only. So I got x as a sine theta, but I have to find the value of theta also, sine inverse of x by a, just to use it later. No problem, right? Okay. Solve it from here. We'll get tan inverse. X is nothing but a sine theta, and inside you check a square minus a square sine square theta. Okay, take a square common. It'll become 1 minus sine square theta. A square into cos square theta. Apply root, please. Answer is a cos theta. What's the answer? A cos theta. Life easy now? Yes, sir. Tan inverse of sine by cos, tan theta. What's the answer, sir? Theta. What is theta, sir? Sine inverse of x by a. Sine inverse of x by a from here. That's my answer. Clear? This is a simplified answer for this one. Okay? Why is it important? Plays a big role in the questions of derivatives, integration, and so on. Question number 10. This is clear. Question number 10. Find the values of each of the following. How do you solve it? Okay, not each of the following. Find the values of the following. Actually, it had multiple options, but they were very similar. I've taken some of them as homework. That's why I took only one of this question. It's a PYQ, that's why. Okay. Find the value of the following. Okay, let's go like this. Tan inverse. I think I solved this question, no, already. 2 into cos. I think I solved this question. 2 into pi by 6. Yes, no, I think I solved it. It was coming as pi by 4. Please check, guys. Same was a PYQ, no, over here. Yeah, here. It was pi by 4. Check. Same question has been asked for. If there was 2 options over here, no? So also the same question. Now this is also if you solve it. So please solve it. Solve this one and verify this. Answer will come as pi by 4 only. Cos pi by 3 will be 1 by 2. 2 cancels. Tan inverse of 1 is pi by 4. Did I go too fast about this? No, right? Let's solve these 2 questions. Simplest form. So let's go with the first one. Tan inverse of cos x upon 1 minus sin x. So tan inverse of, let me do one thing. Just write this part. Cos x upon 1 minus sin x. Cos square x by 2 minus sin square x by 2 by 1 minus sin x, no? So we have cos square x by 2 plus sin square x by 2 minus 2 sin x by 2 into cos x by 2. Clear, na? How come, sir? How come, sir? Okay. How come? Let me show you. Let me show you. 1, because of this, sin square plus cos square is 1. Sin x formula is 2 sin x by 2 and cos x by 2. 2 sin x by 2 and cos x by 2. Okay. Not visible? I'll write it again. No problem. Check this out. This expansion. Cos x by 2 minus sin x by 2 into cos x by 2 plus sin x by 2 divided by, check here, a square b square minus 2ab. So cos x by 2 minus sin x by 2 the whole square. To the whole square. This will cancel. One of them over here. Now you check. This whole thing has become actually, what is this? This whole thing has become cos x by 2 plus sin x by 2 upon cos x by 2 minus sin x by 2. Divide by cos on both sides. You'll get both up and down. 1 plus tan x by 2, 1 minus tan x by 2. Do you know the formula of this? Yes. This is nothing but tan of pi by 4 plus x by 2. How come, sir? Tan a plus b. Tan a, tan pi by 4 is 1. Tan of a plus b. A is pi by 4. Tan pi by 4 is 1. Tan x by 2 plus, that is in plus, in the denominator we have tan of pi by 4 will come later. We still have 1 minus tan pi by 4 will be 1. So 1 minus 1 into tan of x by 2. So this is the formula. You should know all this formula, but still, okay? Giving you an explanation. Got it? Now the last step. We got this for this thing. Put back in the equation. Tan inverse of this particular value, tan of pi by 4 plus x by 2. What's the answer? Pi by 4 plus x by 2. This question has been asked in the CND also. Okay? Alright? Okay, sir. Next what? Next what? Cot inverse of 1 upon x square minus 1. Do one thing, solve it over here. X equals to, if you take cot inverse is there, na? Take x equals to sec theta. You'll get the answer. Apply this. This is your hint, okay? I solved it right now for you, but this is your hint. P by Q. X as sec theta. 12th one. Find the value of each of the following. Let's solve it. Very simple. Check here. Take x as tan alpha. Here you're gonna take y as tan beta. Okay, tan beta. Check over here. You're gonna get what? I'll just write on this side. Sine inverse of sine 2 alpha plus cos inverse of cos 2 beta. Because this is the formula of sine 2a and cos 2a. What is this? 2 tan a upon 1 minus tan square. 1 plus tan square is, what is it? Tan 2a. This formula, 2 tan theta upon 1 plus tan square theta is what? Sine 2 theta. And what is this? 1 minus tan square theta upon 1 plus tan square theta is what? Cos 2 theta. I've used that only over here. Okay? Now check. So basically I'm getting this over here as 2 alpha, here as 2 beta. Take 2 common, alpha plus beta. Now bring back this value. What do we have? 1 by 2 outside. What do we have? 1 by 2 outside with tan. 2 and 2 goes out. 2 and 2 goes out. Now what I have left? Simply tan alpha. What is alpha? If x is tan alpha means alpha is tan inverse of x. Tan inverse of x. What about this? Y. I have tan outside. I cannot apply right now, but if I can get them as same, if I can make them one value of tan inverse, then I'll get the answer. Okay? Right here tan, and check this out. Tan inverse plus tan inverse. This becomes tan inverse of x plus y upon 1 minus xy. How, sir? It's an identity. Okay? Do check it out. Apply this tan to tan inverse. Answer is going as x plus y upon 1 minus xy. This is my final result. Okay? My final result is right over here. Done? Okay. 12th one is clear. Next. Last type is 3 marker. So first 8 questions, next 4, so 12. Now next is 5 questions. Okay. Solve the equation tan inverse 1 minus x upon 1 plus x. But it's very simple, right? This will become what? Tan inverse of 1 minus tan inverse of x equals to half of tan inverse of x. We just solved it right now. Please check. Same formula we use, no? Tan inverse of x plus y upon 1 minus xy we have. In this case we have 1 minus x. Same thing. Okay? This is the formula of tan inverse of 1 minus tan inverse of x. This whole thing, the LHS side. So this will become what? Pi by 4, 1 by 2 plus 1. Take tan inverse of x common. Correct, na? right? Now we have this 1 over here, this is 1 by 2, will become 3 by 2. Check now. Pi by 4, 3 by 2, tan inverse of x. 2 2s are 4, 3, sorry, not cancel, it'll come down actually. So we have the answer over here, pi by 6 equal to tan inverse of x. So x is tan pi by 6. Tan 30 means x is 1 upon root 3. What did they ask? They asked us to solve it. We got it done. X value is coming as 1 by root 3. Okay, question number 14 now. Look, the thing is, for some students this confuses too. The questions of ITF confuses, but if you know the identities, if you ask me, sir, why ITF is difficult, I'll say, bacha, you don't know the formulas of trigonometric function. If you actually do know the formula of trigonometric function, then this is very, very easy. Can you see how fast we can solve the questions? This is clear. Moving on. Write the simplest form of this. Divide by cos. Tan inverse of 1 minus sine by cos, na? Sin x by cos x upon 1 plus sin x by cos x. What I get? Tan inverse of 1 minus tan x. I hope nobody has doubt about this step, right? The first step. Why can we divide by cos? Because we can do the same operation on both numerator and the denominator. So I divided by cos to make it tan and 1. Now you check the formula. Again, same thing, sir. Yes, it is the same thing. Tan inverse of, what is it? Tan of pi by 4, na? Minus x. Tan of pi by 4 minus x. So what I get for this? Pi by 4 minus x is my answer. 3-mark question. Okay, done, easy. Next one. Prove that cos inverse of 4 by 5, cos inverse of 12 by 13 is equal to cos inverse of 33 by 65. Okay, take this as value A, this as value B. We'll solve this one later. So why is the value A, B? Cos inverse output is an angle. I've taken the angle as A and B. I can do that. Okay, sir. Now try this triangle. If this is my angle A, sir, then what is they've given? They've given that, sir, that cos of A is 4 by 5. So this is, sir, 4. This is 5. Now we all know by Pythagorean triplet, this will be 3. 3, 4, 5 is what? It's a Pythagorean triplet. To make this triangle work, the ratio has to be 3, 4 and 5. Okay? Alright, sir. Cos A is 4 by 5. Okay. Can I make another triangle over here? Yeah. Again, this is angle B. Over here what we have? 12 and 13. 12 and 13. So, of course, this has to be what? 5 only, no? 144 plus 25. 144 plus 25 is how much? 169, which is 13 square. What they have given? Cos beta. Cos beta or cos B is 12 by 13. Check here, please. Clear? Now, take LHS. What have they given in LHS, sir? They have given A plus B. No, sir, they did not give. Yes, they have. I have assumed the angle to be A and B, so they have given A plus B only, no? This is angle, this is angle. I have taken as A and B. This is A plus B. Problem? No. Now apply cos on this side. Cos of A plus B. Why, sir? Why can I do that? I can apply any formula, right? I can apply any formula. Okay, sir, if you say so. Apply cos of A plus B. So this is cos A, cos B minus sin A, sin B. Sir, we don't know sin A, sin B. We don't. Check from here, sin A. 3 by 5, sin B. 5 by 13. Opposite by hypotenuse, 5 by 13 and 3 by 5. Use it over here. So we get this as 4 by 5 into 12 by 13 minus 3 by 5 into 5 by 13. Check here. 48 minus 15 by 65. 48 minus 15 by 65. Difference is what? 3 by 65. What is this, sir? This is nothing but, sir, cos of A plus B equal to 33 by 65. Take cos inverse on this side. Sir, a plus b is equal to cos inverse of 33 by 65. I hope you're getting right. What I'm doing over here, basically I'm taking cos inverse on both sides. So this will become cos inverse of cos, cancel. This is going to be cos inverse of 33 by 65. Check here. A plus b was what? LHS. What is this? RHS, na? Proved? Yes, sir. Hence, proved. Done. As easy as it gets. Very, very simple. Just break down the problem step by step, and result is on the screen for all of you. Any problem, any doubt, let me know in the comment section. Okay? If you solve your homework, I'll discuss in the session. If you don't solve, I'll not discuss. Okay? Then it's waste of my energy. This is done? Okay. Prove that tan inverse of root of 1 plus x minus root of 1 minus x is going to be this. Difficult? No. Check here. 1 plus x. What is 1, sir? 1 is sine square x by 2 cos square x by 2. Okay. Sine square x by 2 cos square x by 2 is your this value. What is x, sir? Sine theta. Take x as sine theta. Take x as sine theta. So it will become, I'm taking this x as, excuse me, sine theta. So it will become what? Plus 2 sine theta by 2 into cos theta by 2. So again I'm getting here 1 plus x as cos theta by 2 plus sine theta by 2 the whole square. Check. A square b square 2ab. A plus b the whole square. Okay, sir. Take root. So then this is cancelled. Okay, sir. It means that root of 1 plus x is nothing but simply cos theta by 2 plus sine of theta by 2. Okay, sir, you did for 1 plus x. Let's do now for 1 minus x. Do we need to? Right here minus, right here minus. Because this is nothing but 1. This whole thing is 1. The minus sign is over here. If this is minus means this will be minus, this will be minus. That easy. Now you check. So do we need to write this? You can write similarly 1 minus root of 1 minus x is cos theta minus sine theta. Don't have to write all the steps. Just I'm explaining this with the help of steps. Okay? You have to write similarly root of 1 minus x is cos theta minus sine theta by 2. Not writing all the 3 steps. Okay. Done, sir. Apply from here. Tan inverse of cos theta by 2 plus sine theta by 2 minus cos theta by 2 minus sine theta by 2. Close the bracket. Check here. Check here, please. This cos will cancel. Cos minus cos will be cancelled. What do we have left? Sir, why not denominator, sir? You'll see. Sine plus sine is what? 2 sine theta by 2. 2 sine theta by 2. You can take this as 1 plus x. If you take 1 plus x, no? If you take x as cos theta, that also can be solved. Okay. I think this way also works, but we'll see. Okay, I did not see the RHS side. We want here cos inverse, no? We want cos inverse here. Okay, sir. I'll try solving this way. It doesn't work, then basically what we have to do now, I have to take x as cos theta, then we can use different approach. For all of you who want to try this. 1 plus x is there, no? So take x as cos theta. It will become 1 plus cos theta. So what is this going to be? 2 cos square theta by 2. And for 1 minus cos, no, it will become 2 sine square theta by 2. Okay, so I have made a mistake over here. What I have made a mistake? That I did not see the right hand side part. I'll try to solve using this way also, it should work. But just telling you, if you want to, the faster way, the better way, the correct way, because I did not see the RHS side, I went with this method. But what you can try is simply take x value as cos theta. I have taken x as sine theta. Remember, check here please. I have taken x as sine theta. I am asking you to do the what? Take x as cos theta. This is the faster and better way. But since I have taken this step already, I'll try to solve and simplify from this here also. Please check. So 1 plus cos here, this will become 1 plus cos, no? Because x is taken as cos, it will become 2 sine square theta, 2 cos square theta. So I'll have the answer as root 2 cos theta. Here I'll have root 2 cos theta. Here I'll have what? Root 2 sine theta. Okay, check. So I have 2 sine theta by 2, and over here same way I'll have here as 2 cos theta by 2. So I'm getting here what? 2 cos, excuse me, 2 cos theta by 2. 2 cancels. Tan inverse of this will become what? Simply theta by 2. Simply theta by 2. Correct, no? Because sine by cos is tan. Tan inverse of tan will become theta by 2 only, no? What is this? This whole thing is nothing but tan theta by 2. Tan inverse is outside, it will become tan inverse of tan, so theta by 2 is the result. What is theta? Theta is nothing but, please check here. So if I write theta over here, it will become sine inverse of x. Sine inverse of x. Sine inverse of x by 2. X by 2. But I want the answer in terms of pi by 4 minus cos inverse of x. I can get that. Wait a second. So if I take this as some angle, let's say alpha, okay. If I take this some angle alpha, okay. If I have over here alpha, then I have what? I have sine inverse sine of, okay, no. 1 second. Theta by 2 is, excuse me guys, I'm just thinking, what way we can get the same answer? We can apply the complementary ratio and get the same answer. Theta by 2, if I take directly from here, it will become what? It will become sine inverse of x by 2. Okay, that is correct. X by 2, this is correct. If I take this as, let's say, some angle alpha, if I'm taking this theta by 2 as some angle alpha, I'm trying to reach from here to this part. So 1 by 2 is equals to sine inverse of x. Bring here alpha, it will become 2 alpha equals to sine inverse of x. Bring back over here, you'll get sine of 2 alpha equals to x. Okay, so we can write this as cos, check here, cos of pi by 2 minus 2 alpha, no? Yes, equals to pi by 2 plus alpha. Will it work? No, minus only will work, as x. Now I think it should work. Is it working? If I do it like this, it will be sine 2 alpha only. Cos of pi 90 minus 2 alpha is sine 2 alpha. And over here what I have this as, I'll get something. Let me solve it from here. So I'm getting here cos, I'm getting this as pi by 2 minus 2 alpha. Excuse me, I'm lost over here a little bit. 1 second. Pi by 2 minus 2 alpha equals to cos inverse of x. So I've got at least cos inverse. Yeah, cos inverse of x. Now if I bring on this side, I'll get pi by 2 minus cos inverse of x equals to 2 alpha. Right now, equals to 2 alpha. Check here. So I have, yes, I've got the answer. Now I'm getting I need the value of alpha only, no? So this will come over here. So pi by 4 minus 1 by 2 cos inverse of x equals to alpha. What was alpha over here? Alpha was sine inverse of x by 2. Alpha was sine inverse of x by 2. Okay. Now what was this value? This was the value of this answer. So yes, I use a different method which is more lengthier. You should not follow it. Please don't mind, because I did not see the RHS side. I went a little faster on that side. So use this method. Take x as cos theta. 1 plus cos will give me 2 cos square. 1 minus cos will give me 2 sin square. Then you're gonna directly get what? Root 2 cos minus root 2 sin. Please check here. You'll get this as root 2 cos theta minus root 2 sin theta upon same thing, root 2 cos theta plus root 2 sin theta. Root 2 all cancelled. So now you divide by cos, it will become 1 minus tan theta upon 1 plus tan theta. Okay, now you all know this will become what? Tan of pi by 4 minus theta. Now apply tan inverse on this. Check outside is tan inverse. So answer will become what? Pi by 4 minus theta. What is theta value? If you have taken x as cos theta, theta value is cos inverse. So you'll get here pi by 4 minus cos inverse of x. This is theta by 2, no? Sorry. By 2 everywhere. Here also 2. Here also 2. Here also 2. This will become what? Theta by 2. So answer is cos inverse of x by 2. Pi by 4 minus cos inverse of x by 2. Clear? Okay. So this is the method number 2, which is the faster method. Use this method. What I've done, taking x as cos theta and applying like this. 1 plus cos is 2 cos square, 1 minus x is 2 sin square. Forgive me for taking two methods and taking it longer, but yeah, I didn't want to say that this is also wrong approach. This is the correct approach. We got it. We got the result of this whole thing as 1 by 2 sin inverse of x, and I have taken this as alpha and proved that this alpha is actually, if you change from here, is coming as what is it? Pi by 4 minus 1 by 2 cos inverse of x. Please check. Same as this one. Yes, clear, right? Both of these are clear. Okay, 16th is good question. I use the wrong method, but very easy question, very easy question. Okay, so use the right method. This is the correct method. Correct method. Okay. Okay, now question number 17, let me solve it. I have not take the space because I have used two methods. I have to solve it over here only. 2 tan inverse of cos x. 2 tan inverse of cos x. And what do we have? 1 second. The last question, just give me 1 minute. Tan inverse of 2 cosec x. Tan inverse of 2 cosec x. Okay, we have to solve this only, right? Yeah. So the problem is what over here? The problem is that we are having 2 tan inverse. Otherwise we can cancel, right? The formula of this is there, no? Tan inverse of 2 cos x upon 1 minus cos square x, no? 1 minus cos square x, that's the formula. How come, sir? The formula is there, please, you have to remember the formulas. Yeah, so 1 minus cos square x, this is the formula of 2 tan theta. So if you have 2 tan inverse, no, that is the formula, tan inverse of 2 cos x upon 1 minus cos square x. This is nothing but, here also tan inverse of 2 cosec x. Tan inverse is here and here, we can apply tan on both sides, tan inverse will go away. Now we have left what? 2 cos x upon 1 minus cos square is going to be sin square, no? And here we'll have, what is this going to be? Tan inverse of 2 cosec x only. 2 cosec x only. So I'm getting this 2 and 2 cancelled. What I have, check this out. So I'm getting this value as, let's cross multiply. I'll get 1 by sin. So I'll get sin x cos x equals to sin square x. Right over here, I'll get sin x common. Cos x minus sin x will be 0. Correct, no? If I take sin square over here, it will become minus sin square. If I take sin common, cos minus sin will be left. Check here. From here I'm getting sin x as 0. From here I'm getting cos x equals to sin x. Cos x equals to sin x. Sin x 0 means from here I have to get x value is 0 or multiples of pi. X value is 0 or multiples of pi. But if you take x as 0, cosec will become undefined. So this is not possible. This here is not possible because if you take x as 0, cosec of x is undefined. Okay, so we have to use something over here. What is that given? Cos x equals to sin x. From here what I get? Tan x divided by cos. Tan x equals to 1. X has to be what? N pi plus pi by 4, no? Basically multiples of pi by 4. So I'll get this answer. If I'm looking for a principal value, I'll get this as pi by 4 only. This will be pi by 4 only. The first value, the principal value will be, this is your principal value. Principal value will be pi by 4. But if you want a general answer, n pi plus pi by 4. Done? Check here. Sorry, plus minus, no? Both are true. Yeah, so this is the part 1 answer, the 17 part 1 answer. Let me go to the part 2 now. Part 2 is here. Check this out. Part 2. Sin inverse of 1 minus x. Okay. Sin inverse of 1 minus x plus, minus or plus? Minus 2 sin inverse of x equals to pi by 2. We have to prove. We have to prove equal to pi by 2. Okay, sir. Move on this side. It will become what? Pi by 2 plus 2 sin inverse of x. Pi by 2 plus 2 sin inverse of x. Now take sin on both sides. It will become 1 minus x, and over here you'll have sine of pi by 2 plus 2 sine inverse of x. 1 minus x as it is. Over here what I get? Sine of 90 plus some angle. Sine of 90 plus some angle. How come angle, sir? Sine inverse is some angle into 2 will be some angle only. So the sine of 90 plus some angle, second quadrant, positive only. So it will become cos. Excuse me. Something is wrong. Pi by 2 only. Correct, na? Pi by 2 plus. Okay, apply sine, will become cos only. Yes. Cos of 2 sine inverse of x. Cos of 2 sine inverse of x. Okay. So far so good. Alright. So cos of 2 sine inverse of x we have. But we use the cos part. Okay. You have to change this now to sine inverse of x. Okay. So what we have now? 1 minus x equals to, what do we have? 1 minus x equals to sine of this. So cos of 2 sine inverse of x. Cos of some angle. Cos of twice of some angle. 1 minus 2 sine inverse of, correct, no? Cos of 2 sine inverse of x. So 1 minus 2 sine of sine inverse of x. Yes, sorry. Yeah. Sine square of sine inverse of x. Right? That's the formula, no? Cos 2 theta will be 1 minus 2 sine square theta. So what we have answer as 1 minus 2. Sine of sine inverse is simply x, square of that, so 2x square. And we have 1 minus x over here. 1 and 1 cancel. Bring on this side. We get here 2x square minus x. Take here from this x common. I'll get x into 2x minus 1 equal to 0. So it gives me value of x as either 0 or 1 by 2. X is as 0 or 1 by 2. Okay. Now if you check over here, which is satisfying, if I put here 0, it will become sine inverse of 1. It will become minus sine inverse of 1. Yeah, that is correct. If I put x as 0, it is satisfying, no? This will be what? Sine inverse of 1 minus 2 sine inverse of 0. This is going to be 0 only, right? And this will be what? Pi by 2. Sine inverse of 1 is what? Sine inverse of 1 is going to be pi by 2 only. So this is satisfying. Let's check 1 by 2 now. So for 1 by 2 if I take, I'll get sine inverse of 1 minus 1 by 2 is how much? 1 by 2. And we get minus 2 sine inverse of 1 by 2. So I get here, this is same thing, no? So minus, it's coming as negative value. Minus 1 sine inverse of 1 by 2. Basically this is coming as, 1 second. I can write it better. Yeah. So sine inverse of 1 by 2. This is coming as basically minus pi by 6. Is not equal to pi by 2. So if you check the two values that we got, 0 and 1 by 2, this is not working. This right here is not working. This is the correct one. So answer is what? For this part, answer is x equal to 0. And for this part, answer was what? For the first part, answer was pi by 4. Please check. Clear? No, both parts are clear. This is 17th. This is answer for question number 16. Question number 16th answer. Please check, guys. No confusion, right? 16th answer, 17th answer on the next page. This is on the next page. Next page. Over here. Please check both of these. I know a little bit messy, but why did I continue with this step? No, because usually what happens as a student, we do get stuck. We do get stuck in the question, and because we chose a different way in the examination, our mind can work like that, right? You can make a mistake that I also made. But if you continue this way also, if you don't waste time, if you continue this way also, if it is possible, you'll get the right answer even from that method. So that also works out. For maths, there's no standard methods. You can apply your own learnings always. Okay. So this is done. 16th also done. 17th is here. This is 17th part 2. Little bit messy. I hope you have taken screenshots and copied it. 16th from here. Clear? 17th. This is again 16th only. 17th, and this is your homework. So today I have given you 4 questions. This. All of them are 3 marker. All of these are 3 marker. So this completes your chapter, inverse trigonometric function from the PU2 syllabus. Now if you ask me the most important topics, first of all it has to be MCQs. very relevant. Then comes your domain and range and graph of ITF and formulas of trigonometric identities from the PU1. So do remember all these topics, do go through it, and this is the end of your session. If you are watching me for the first time, if you're here learning from me for the first time, if you're here listening from me for the first time, do subscribe the channel. We are working really hard over here to make sure that everything that you need to get the top 95% marks in your PU2 boards will be delivered in the Brahmastra 2.0, and so many things are also planned on our channel. So do make sure that you are with us, you have joined us, and we are continuing the journey with full motivation and consistency. Okay, so let me know if you have any feedback, if you have anything to say to me. Do speak to me, and thanks for listening to me in this particular session. I'll come back with another interesting and informative lecture which will help you to get covering that one particular topic and will add a value to your preparation. This is it for in this particular session. I'll see you again very soon. Till then, take care. Bye-bye.